Okay, sometimes when you do electron configurations, you need to write them out with pairing, and what pairing's talking about, it's really pretty simple. If you can write out an electron configuration, you can do pairing. I mean, it's very simple. If what you're doing is, let's say you have like 1s2, you'd have an electron pair like that. What you're doing is it's pretty self-explanatory. Electron pairing is you're pairing the electrons, or in some cases you're not pairing. They'll go in something like this. They'll go in singly, S-I-N-G-L-Y. I think that's how you spell singly. And then what would happen is if you got more electrons after that, they would come in one at a time. And this would happen in the example of a P, well, it's not a good P subshell. The reason for that is because in a P subshell, it has three orbitals. Okay, so I made a different video on this before, and maybe you watched it, maybe you didn't, but in that video I broke it down and I said we have 1, 2, 3, 4 shells, and then I said you have the S, SP, SPD, and then you have SP, D, and F block, and then you have orbitals in there, and you have 1, 1, 1, 3, 1, 3, 5, 1, 3, 5, and 7, and then you have 2 electrons per orbital. We have 2 electrons per orbital, so we'd have 2, 2, 6, 2, 6, 10, 2, 6, 10, 14. So it would give us a total of 2, 8, 18, and what, 30, 32, right? 10, 20, yeah, 32. Okay, so if we look at the P subshell, the P subshell has three orbitals, so it has six electrons that could go in it, but it has 3 orbitals. So if we looked at it, and I forget the shape of a P orbital. I'm trying to remember what it is. I want to say it's like the hourglass type shape, but could be wrong. Don't quote me on that. Okay, those are horrible drawings, but what can you do? Okay, so if these are orbitals, we would have 3 of them. We would have 6 electrons that could go in there. So we would have 1 electron that would go in. So that would be 1 arrow. Okay, so we would say 1 electron, and then we could have another electron, but that electron could not pair up. Okay, the second electron to enter could not pair up this way. The second electron to enter would have to go in a separate orbital. The reason is because when another electron enters a subshell, it goes in another orbital. It doesn't go in the same orbital. Okay, they enter orbitals separately. They enter orbitals one at a time. Okay, that is a sequence. That is the rule of how they enter. Okay, so one would enter here, then one would enter here, then one would enter here. Okay, so then if we had 4, in the case where we had 4, we would have something that would look like this. If we had 5, we would have well, we'd have another electron there. If we had 5, we'd have another electron here, and we would have something that looked like that. If we had it completely full, we'd have a 6th electron there, and it would be full like that. And then they would all be paired. Okay, so let me do an example now. So why don't we clear this? Save. Okay, so let's find Okay, let's use fluorine for our example. Okay, let me find fluorine on my, well, let's see if I can bring up a periodic table for us to look at. Okay, so fluorine has an atomic number of 9, so let's write that. Atomic number of 9. So without even looking at the periodic table, we could probably do that because we've done many examples of these, but let's look at it anyway. So we have 1s2, we have 2s2, we have 2p, and then we just need to fill the number of electrons to get to fluorine here. So we wouldn't have it full at 6, but we would have 5. So we would have 2p5. So let's write that out. So we'd have 1s2, 2s2, and 2p5. And remember we said we had 9, so if we add those up, we have 5, 7, and 9. So that equals 9. So we're good. But now, the point of this video is to do the electron pairing. So what we would have is we would have our S subshell, and those would be paired because there's only 2 electrons in there, and well, they're paired. Okay, now same thing would go with the 2s. Those would both be paired as well. Now we get to the 2p, and this is what I just drew out before. We would have one enter at a time. So this is where I had three orbitals. So they'd enter one at a time. I'd have 1, 2, 3 electrons, and then I'd have my 4th electron and my 5th electron. Okay, so if I only had 4 electrons, well, if I had 4 electrons, it would look like that, and we'd be talking about oxygen. If I only had, what, 3 electrons, it would look like this. We'd be talking about, what would we be talking about? Nitrogen here. So if I had 2, we'd be talking about, what, carbon? Let's see, is that right? 1s2, 2s2, 2p, so it would be 2p2 in this case. It would look, yep, it would look like that, and except instead of 5 there would be a 2. Okay, so the point is these fill one at a time. Fills one at a time, so it fills like this. And then after they're all filled, then they start pairing. Then they start to pair like that. So that's how you do pairing with electron configurations.